Hello, everyone. My name is Liu Tao, and I'm from the University of Aizu. Okay, today I'm gonna present my paper, which named AppSense, detecting smartphone usage via Wi-Fi signals. This is the outline, which including the background, the system design, the evaluation, and the final conclusion and the future work part. So we're first talking about the background. According to the data from Pew Research Center, the average global popularity of smartphones has reached about 16%, and the highest country has even reached about 94%. That means almost all of us have a smartphone or even more than one. So in the view of the frequency with which we carry and use our smartphone, knowing the smartphone usage habit become important. So as you know that there are also some smartphones now have the built-in application monitoring programs to show the use duration of each application, just like the screen time function in the iPhone. So, however, this kind of function will occupy the resource of the smartphone, and they do not provide the raw data for the self-service analysis. There are also some other ways called the side channel to get the usage information of the smartphone. They detect the smartphone usage with like the built-in sensors or the handset. However, this kind of method need to put detection device very close to the targeted smartphone, or they even need to compromise the smartphone software, which is difficult in practice. And here we considering using the Wi-Fi signal as the sensor to collect the operation information of the smartphone, because the fluctuation of the Wi-Fi signal can be associated with the movement of operating smartphone. And the advantages here is also obviously, which including the device free, and because Wi-Fi signal has a wide transmission range, which means we can get a wide sensing range. So next part is the system design. Here we first have some preliminary analysis. As you can see from the figure 1, when a user is operate the smartphone like slide, the channel state information of the Wi-Fi signal will be influenced by the movement. So the user's habit of using the smartphone can reflect in the operation of the phone. Therefore, our goal is to recognize the different gestures of the user. Here we give some preliminary experiments. First, as you can see from the figure 2, compared to the static scenario, the movement will cause the change of the Wi-Fi signal, and from the figure 3 we can find if we doing different operation or the movement, they have different influence on the signal level. So that's why we can identify different operation of the smartphone. Okay, there are also some challenges here. The first is the adaptability to difficult perceived environments, because unlike the wearable device, which can get stable monitoring data, the device free means there are more uncontrollable factors. The users may switch back and forth between a Wi-Fi connection and a cellular data connection. So the second challenge is the mapping of each action's unit characteristics to the wireless signal. The wireless signals are unstable in their own right and are susceptible to multiple effects. There are also some related works that try to sensing the movement with Wi-Fi signal. The most of this work focus on recognize the large size movements, like for example, the walking, the run, the stand up, the sit down. However, the operation on the smartphone is large size movement and have higher demand. And the Wing Talker and Wi-Pass, they use the Wi-Fi signal to identify the operation of the phones to unlock the phone. However, their work restricted that the mobile phone must be the signal transmitter, which means they have limited usage scenarios. The Wind Talker even must use directive tuners, and both of them need numerous attempts before unlocking the smartphone. So here is our AppSense system. As you can see from the figure 4, our systems contains stereo model. We develop a model of data receiving, which including different use things. Then the received data was sent to the pre-processing model for denoting, and the final model is to training and testing the collected data. So the first is the data receiving model. As you can see from the figure 5, there are two typical scenarios. The first, the smartphone directly connected to a laptop or router. We call it AP mode, because now the smartphone working in the AP mode. And there are also another thing that the smartphone do not connected with any devices, but the environment has the Wi-Fi connection. For example, the router connected to the laptop. Even the smartphone do not connect to the Wi-Fi signal. The operation on the smartphone will have influence on the signals in the environment. So these two modes corresponding to two use things, and our system can work well in both of them. The next is the processing and the training. Pre-processing, here we choose the Butterworth's low-pass filter. As you can see from the figure 6, the filter can denoise the roll date. And here we choose the common Cheng algorithm to train the model. And here we choose some features which including like the standard deviation, the average absolute error, the skewness. So the next part is the evaluation. So here is the figure 8 shows the environment of the implementation of our systems. Here we choose 7 different operations on the smartphone, including like the click, the long press, the horizon sweep, the vertical sweep, double click, press the power button, and the static. And the hardware including 2 mini PCs with the Intel 9CS. And we convene 11 experimenters, including 4 female and 7 male. And we random select 18% of date for the training and leave the rest for the testing. In the figure 9, show the results on different things. So under monitor mode, we change the distance between transmit antenna and the receive antenna from 40 cm to about 120 cm. We also test in both LOS and NLOS paths under each distance. We can find that the average recovery accuracy is larger than 18%. Under the AP model, we also let the smartphone be a transmitter with different distance from the receiver, and the average accuracy is always larger than 17.5%. Okay, the last part is the conclusion in the future work. So for the first and the conclusion, in this paper, we present a wireless mobile sensing system, which named the AppSense, and we propose the perception scenarios, including the both AP mode and the monitor mode, corresponding to the smartphone connected to the devices by the Wi-Fi signal, or the smartphone do not connected to the Wi-Fi. And we further utilize the low-pass filter to remove the noise and classify the operation gestures with the Cheng algorithm. And we prototype the AppSense in the real environment, and the experimental results demonstrated the effectiveness and robustness of our systems. So in the future work, we're considering that more data from more people needed to gather, and we maybe need to try some new method like the neural network, and they may have better results. And we also considering directly mapping the gesture to the specific application usage, like gaming, watching movie, or chatting, because in this different usage, they may contain different operation gestures. For example, in the gaming, maybe the users need to operate the smartphone very frequently. But when the user is watching a movie, they may do little operation gestures. The changing, maybe he need also do the gestures frequency, but should be in a different way compared with gaming. So we need to, we will have a try to directly map the gesture to the application usage. And this is the future work, and this is all. Thank you for listening.